So here's our sample question that has to deal with scientific notation. There's only going to be one question on this on the test. But how do we handle this? Again, we know that we have a decimal number here, and we want to have it condensed without so many zeros. So we're going to write this in scientific notation. If you forgot the steps, remember it's 5 steps. Our goal is to make it look like this. Some type of decimal number between 1 and 10 times 10 to some exponent, maybe positive or a negative exponent. So you know this first step is locate the decimal in the original number. And if you don't see one, then you're just going to tack on one at the very far right-hand side, at the very end. So in our case, we do have a decimal point. What you're going to do is move that decimal point behind the first digit when reading from left to right that is not a 0. Once we do that, then what we want to do is count the number of digits between that old decimal point and new decimal point. Remember, zeros count as a digit. That's going to be your exponent. Then you need to have a sign for that exponent. It's either going to be negative or positive. It really depends on how you move the decimal point. If you move the decimal point to the very end of the problem, then you're going to use the negative exponent. If you move the decimal point and it now is in front of the number, then that's when you're going to use a positive exponent. And then finally, rewrite your decimal number. Make sure it's between 1 and 10, and that zeros that are at the very beginning of a decimal point or zeros at the very end of a decimal point are not written. They're not necessary. But zeros that are sandwiched between any other digits, you have to keep them. So let's take a look. We already told you that this one has a decimal point, clearly. It's right here. We want to move it. It has to be moved behind the first digit that is not a 0. But you have to go in this direction, just like you read the sentence, right? In scientific notation, you have to go from left to right. So notice, has to go behind a digit that's not a 0. So 0, 0, 0, 0, 0, 2. Finally, a digit that's not a 0. You're going to move the decimal point behind this 2. So this is the new. That's the old. What you're going to do now is just count the number of digits between that old and new decimal point. So here's the old, here's the new. What's sandwiched between 1, 2, 3, 4, 5? So that means we're going to have times 10. Remember, I always said that's the base of 10, always there. Make sure that you put the 5 as an exponent. I always get someone who does times 5. I'm like, no, the 5 is an exponent. You must remember that this has to be there, base of 10. Then let's figure out, is it going to be a positive exponent or negative? Well, let's see how we move the decimal point. We started here, but we moved it to the back, to the rear. So because we moved it backwards, then this has to be a negative exponent, right? If you moved it to the front, then you use positive. Next, we got to rewrite the decimal point. Remember, it's no longer here, it's here. So let's write this as a new digit, a new number that's between 1 and $10. So see all these zeros that are in front of this decimal point? They're not necessary. So I'm not going to write these, the guys, out. But this 2 I am, okay? I only crossed it out to help me count, but that 2 is still there. Then the decimal point, the new decimal point. And then see these zeros? If this guy wasn't there, then you're correct to get rid of the zeros. But because this 0 is sandwiched between 2 other digits, you have to keep. This is necessary to keep these zeros. Okay, so zeros, if it was here or here, then you would get rid of. Zeros at the very front, you would get rid of. But zeros that are sandwiched, you have to bring down. And then there's no sign here, so then leave this as a positive. And double check. Is this between $1 and $10, $2, and basically half of a penny? Yes, that's definitely between 1 and 10. And and you have your times, and you have your base of 10, and you have your exponent. So this one is good.